Well, you made it. It's our last video on periodic trends. This video is about the trend for ionic size and electronegativity. After this video, you should be able to explain the trend for ionic size and electronegativity, compare the size of cations to the size of anions, and provide explanations for each of these trends. Let's talk about cations. Remember, cations, these are the ones that lose electrons. These are atoms that lost electrons. And as it turns out, cations are always going to be smaller than the neutral atom from which they are made. As your electrons are lost, sometimes there's a loss of an energy level. And remember, if there's a loss of an energy level, there's a decreased distance, and so therefore there's going to be greater attraction. Those energy levels are simply going to be pulled in a lot more. Also, with more electrons being lost, there are less electron repulsions, and therefore, if there's less electron repulsions, there's greater attraction to the nucleus. The more electrons lost, the smaller the ion becomes. For example, if we look at the magnesium atom to the magnesium 2+ ion, you can see that neutral magnesium is the largest, then magnesium with a +1 is smaller than that, and then magnesium 2+ is even smaller. Anions, remember, these are the negative ions. These are the atoms that'll gain electrons. These are always larger than the neutral atom from which they are made. The reason why is because as you add more electrons to form these anions, there are more electron repulsions. And this results in less attractive force between the nucleus and the energy levels. The more electrons gained, the bigger your ion is going to be. For example, if you look at oxygen, neutral oxygen is the smallest. But however, as you gain more and more electrons, you'll see oxygen with a -2 be the largest in size. The last trend we have to talk about is something called electronegativity, which we'll explore quite a bit more in our unit on bonding. Electronegativity is the tendency for an element to attract electrons when it's bonded with another element. Fluorine has the highest electronegativity on the periodic table with a value of 4.0. This is a unitless number. When we look at a group trend, we're talking down the group, we will see electronegativity decreases. And again, the reason why is because electrons are less attracted to the nucleus because there's more energy levels. That's where we talk about distance. Basically, the distance between the valence shell and the nucleus is much further. So the electrons really, aren't as attracted. For the period trend, as we have talked about with ionization energy and atomic radius, we know that as we go across, the effective nuclear charge or the nuclear charge increases. And when that happens, that's going to cause more attraction. So therefore, since we are going from left to right when we talk about period trends, that automatically means that the electrons are more attracted to the nucleus. And if they're more attracted, they're going to kind of tug on those electrons a little bit more. This is a cool periodic table to look at. It's called p-table. And basically, it has a bunch of different electronegativity values, which might be helpful for you to see. And you can also select other things here too. But you can clearly see that fluorine is the most electronegative out of all of these elements on the periodic table. You could also see how red it is. But you can see the closer you get to fluorine, the more electronegative it is. For the summary, it's going to look very, very similar to ionization energy. It's the upside down snowman. As you go from top to bottom, you're going to see electronegativity decrease. And as you go from left to right, you're going to see electronegativity increase. Hopefully this video helped you to understand a little bit about electronegativity and what it means in terms of attraction. Also, I hope this video helped you to be able to understand the difference in the sizes of cations and anions. Thank you so much for watching.